Good morning, viewers. This is my second video in continuation with the same session 1 about cognitive computing. We discussed in the previous session about the cognitive system definition and the history of that, and also cognitive science, what is the cognition means, and different processes, what are the disciplines of cognitive science. Now in this session I want to discuss what are the formal models. Quantitative, which is also called as mathematical, or procedural, which is also computer program. Procedures means we have to write procedures in the form of queries or in the form of instructions. It is a program. In computer terminology it is called as program. Quantitative means only it is happened with the help of mathematical equation substitutions. Quantitative are procedural implementations of a theory. The formal model attempts to mimic human data from the tasks they are modeling. In cognitive psychology, formal models exist for memory, perception, language comprehension, decision making, etc. But why? What is the point of modeling? The solution for why and what can explained with the advantages of computational modeling. The advantages of computational modeling, generally I can give, apart from this slide, what is a cognitive system or what is a cognitive science. Can I say a simple example to understand to the viewers? We learnt mathematics from the school days, plus 2 and degree level we are learning. Without mathematics there is no field. So mathematics having several integration, differentiation, quadratic equations, hyperbolic equations, trigonometric equations, all area of circle, perimeter, triangles, all these things, etc. So many are there. But out of which we know some of the formulas, still now we can recollect those formulas where you have to apply, because our brain continuously working on that, thinking on that from the school days. Suppose quadratic equation, real roots, imaginary roots, like that, minus b plus r minus square root of b square minus 4ac by 2a, like that equation you know. Similarly centigrade to foreign heat conversion, foreign heat to centigrade conversion. What is a Fibonacci series, what is the factorial of a number, like that we have like displacement s is equal to ut plus half at square, some formulas. We can apply those formulas in a programming way. You can write a program in C or Java languages later. We are in that stage. But computation system is a thing. Artificial intelligence means global knowledge, entire knowledge is there. But suppose quadratic equation solving, that we are at a stage, what formula to apply for that solving the particular problem. Okay, is that centigrade formula or is an other formula, trigonometric formula is applicable there? No, you have to apply quadratic equation and solving the roots, square root of b square minus 4ac, like that, minus b plus or minus by divided by 2a. So you are having brain and mind, mental ability to apply at a particular instance of time that formula only, not other formulas so called. That is cognitive system. The cognitive system, where and when what to apply to get rid of the solution. So coming to this slide, advantages, but why and what we can explain by taking these advantages. Push predicate aspects of a theory more formal, precise and abstract specifications. Avoids ambiguity, vagueness in theory. Forces a more complete specification of the assumptions of a theory. Quantitative model. Previous slide we discussed about quantitative, computational, like that. Quantitative as well as qualitative predictions, just like they do in the real sciences. How to represent are the knowledge representation and computation. Central hypothesis of cognitive science is that thinking can best be understood in terms of representational structures in the mind and computational procedures that operate on those structures. Much disagreement about the nature of the representations and computations that constitute thinking. The information processing metaphor. Here in this slide there are two different views are there. One is a symbolic view and one is a connectionist view. Mind has mental representation analogous to computer data structures and computational procedures similar to computational algorithms. As we know, data structures are two types: linear data structures, non-linear data structures. In the previous semester you studied about all these stacks, queues, arrays, linked list, trees, graphs, all comes under data structure to store the some amount of data in the form of records or the files you are employing. And computational procedures, you are writing some code, queries or instructions, program code similar to computational algorithms. After that calculating the complexities, big O notation, all these. Mind has mental representation analogous to these. Symbolic view. Mind contains such mental representation as logical propositions, rules, concepts, images and analogies, and that it uses mental procedures such as deduction, search, matching, rotating and retrieval. Logical propositions. The symbolic view, logical propositions means you are, for the simple sentences, you are connecting or representing with an alphabet, capital P or small letter A, B, C, like that. In between that you are connecting with some conjunctions, disjunction, negation, conditional, biconditional, with fully parenthesized, balancing of parentheses, which is in turn called as first order predicate logic. Rules. What are the rules for the symbolic view? Rule P, rule premise, rule conditional proof, rule of implication, rule universal specification, rule US, rule universal generalization, rule UG, rule existential specification, rule ES, rule existential generalization, and also several rules like simplification, conjunction, modus ponens, modus tollens, disjunctive syllogism, conjunctive syllogism, destructive dilemma, constructive dilemma, and other rules can be applied for deducing inference patterns. De Morgan's law, association rule, mathematical rules, De Morgan's law, association rules, intersection, rule of intersection, rule of double negation, images, capturing images, analogies, search, binary search, linear search, best fit search, heuristic search, hill climbing search, matching, pattern matching algorithms are there, rotating and retrieving the information. All these comes under symbolic view. Information, how the processing metaphor. Connectionist view, which is mental representation use neurons and their connections as mechanisms for data structures, and neuron firing and spreading activation as that algorithms. That is, cognition can be explained by using ANNs, artificial neural networks. Is cognition information processing? Yes. Church-Turing thesis, universal Turing machine, the information processing metaphor, which is a combination of data and algorithms. As you know, data is a raw facts, collection of raw facts. Information is a processed data. Algorithms are step-by-step sequential procedures, can be represented English-like language or pseudocode. Principles of cognitive system. What are the different principles? There are three major principles of cognitive system. First one is a learn, second one is a model, and third one is a generate hypothesis. Generate hypothesis. So we will discuss one by one all the principles. Learn. A cognitive system learns. The system leverages data to make inferences about a domain, a topic, a person, or an issue based on training and observations from all varieties, volumes, and velocity of data. Observations from all variety. What is variety? Variety means in the form of types, different types of what? Data. That is a characteristic. Variety of data. There are three different varieties of data. One is a structured data, second one is unstructured data, and semi-structured data. Structured data means in the database management system subject DBMS, we are forming a table, creating a table, inserting values which are tuples, collection of records. That is a structured way. The data entered in the table is a alphabet, numeral, and special symbols, combination of all these. Voluminous and variety. Second variety is unstructured data. Unstructured means images, audio, video files, spatial data. All these are the unstructured one. And the third category of type of data is semi-structured. .csv file, comma separated value, and .xml files are examples of semi-structured data. So this is one of the characteristic of big data. And the second one is volumes. Volumes means high data, huge volume. Who use volumes? Huge amounts. Huge amounts are also called as volume. Means 1 petabyte, more than 1 petabyte. 1 petabyte, yottabyte, brontobyte, geobyte, which is the highest memory unit so far to 2023. Geobyte, 1 geobyte, brontobyte, exobyte. So 1 petabyte more than is called as a huge amount. That is a characteristic of, fundamental characteristic of big data. And velocity of data. Velocity representing the speed of the data. How much time required to insert or to fetch the record, a data or the information from the name node or secondary name node or data node, from a bucket or a rack you are fetching. So these three, not only these three are fundamental characteristics of big data analytics. Second principle is model. To learn, the systems need to create a model to representation of domain, which includes internal and potentially external data and assumptions that dictate what learning algorithms are used. Understanding the context of how the data fits into the model is key to a cognitive system. The third principle, final principle, is generate hypothesis. A cognitive system assumes there is not a single correct answer. The most appropriate answer is based on the data itself. Therefore, a cognitive system is probabilistic. A hypothesis is a candidate explanation for some of the data already understood. A cognitive system uses the data to train, test, or score a hypothesis. These are the three principles of cognitive system. First one is learn, second one is model, third one is generate hypothesis. This is the evolution of cognitive computing. X-axis taken as years, discrete years 1968, 1973, 2008, 2011 and all and so on. Y-axis is a computing, that is a cognitive computing evolution. As we know, in 1950 the origins came out for the invention of artificial intelligence by the Alan Turing. So after from that 1968 knowledge discovery phase is there after 18 years. So what is a knowledge discovery? Representing, we know, knowledge representation, frames, semantic webs, scripts, first order predicate logic, propositional logic, all these things. Identifying the effective, novel, potentially useful and ultimately understandable knowledge from the information represented by various media according to different requirements of applications. 1973, this is evolution phase 1, knowledge discovery to the cognitive science, which is a interdisciplinary study of how information is formed and transcribed in the brain, mainly in computer science and cognitive neuroscience, also including cognitive psychology, linguistics, philosophy, etc. Then the evolution is the third one is big data. The massive complex data sets with 4 characteristics of huge amount, various types, fast growth speed and low value density, which cannot use existing software tools to extract, store, search, share, analyze and process. So in the previous slide I discussed about the big data characteristics: volume, variety, velocity, value, variability, veracity, all these characteristics are there. The fundamental volume, variety and speed, velocity. And finally the cognitive computing in 2011 evolved. The cognitive intelligence depends on the data itself and cognizes the data potential with the ultimate goal of enabling the machine to have brain-like computing. Brain-like computing means human being thinking, mind and brain, like we invented the cognitive computing 2011. The origins for that is big data, cognitive science and knowledge discovery, psychology, linguistics, philosophy and so on. So viewers, with this session I am concluding the introduction. Still we are in introduction concept of cognitive computing. Thank you, and in other sessions we will some advanced topics in the cognitive computing. Thank you very much.